Today we're going to find the area of a trapezoid using our definite integrals. So the area of a trapezoid can be derived or integrated by splitting the trapezoid into three pieces, finding the areas of each piece, and adding them together. So a trapezoid from our algebra has the following equation for its area. 1/2 height times base 1 plus base 2. In order for us to solve for, rather integrate the values for the areas, we first need to come to an agreement that base 1 is equal to b minus a, meaning this area. Once we have that done, we use our definite integrals. For our orange area, let's denote it as f of x sub 1 dx from the limit of 0 to a. For our green area, we have the height, or f x sub 2 dx with the limits a to b. And for our blue area, we denote it as f x sub 3 with the limits at b and b2. Once we have that out of the way, we find the values or the equations for each area as such. For our orange area, we need to use our point slope formula, y equals mx plus b. But since our y-intercept is 0 and as such our b is equal to 0, we only need to find the slope in terms of x. So as such, our slope equation, y2 minus y1 and x2 minus x1, all over x2 minus x1 rather, so h minus 0 and a minus 0 all times x is equal to h over ax. For our green area, we have once again our height in terms of x, and our blue area, which can be denoted by the equation h over b minus b2 times x minus b2. Plugging in these equations into our integrals, we get the following. For our orange area, for our blue area, and our green area and our blue area, and integrating these variables, we get the following: h minus a, h over 2a x squared, h over hx, h over 2b minus b2 x squared, and h b2 over b minus b2x. Plugging in the values, or rather our limits to the equation, we get the following. So an a cancels, and since this can be separated into b2 minus b and b2 plus b, we only need to multiply b2 plus b with -1 so that these cancel out, so we're left with b2 minus b, b2 plus b rather, and here we multiply this by -1 so that we can cancel our denominator and this value right here, which brings us the following. Sorry, I was mistaken. b2 plus b will be the one remaining in this equation. It will be a negative, this will be a positive. So simplifying, or rather expanding these equations, we get the following. Now for this part, we need to combine like terms. As such, we have AH and an AH here, so a half minus a whole becomes a -1/2. BH and HB over 2, so a whole minus a half would be 1/2, and finally HB2 over 2, a half or rather a whole minus a half is equal to a half, which brings us these values, half, half, and half. Simplifying simplifying this equation, we take out like terms, so that's 1/2 and h, so we have 1/2 h times b2 plus b minus a quantity. And as we agreed on in the beginning, that b sub 1 is equal to b minus a, from this part, b minus a is equal to b sub 1. And as such, we get to the equation area is equal to 1/2 h times the quantity b2 plus b1.